person can just see the opposite edge of the bottom of an empty vessel over its beam as shown in the figure A. While keeping the eye in the same position, the vessel is filled with a clear liquid up to its beam. Then he is able to see small mark at the center of the bottom of the vessel as shown in the figure B. The refractive index of liquid is given by. I will get two situations for the same diagram. For the first situation, the line of vision is like this. For the second situation, there is a liquid, therefore the light ray is refracting at this place. Now we can get, for the second situation, incident angle is this one. It is equal to this full angle. And for the second situation, refracted angle is this one. Now we know that diameter of vessel 2r, height of vessel h, then we can get this length 2r squared, it means 4r squared plus h squared square root according to Pythagoras theorem. By using the same method, we can find this length. We know that this is the radius r. Height is same as the previous ray. Therefore, this length is r squared plus h squared root. Now we can use Snell's law for the point x by considering second situation. 1 into sin I equals refractive index of liquid N into sin R. We can substitute sin I by using this large triangle. 2r divided by hypotenuse. Hypotenuse is 4r squared plus h squared root. Should be equals to n times sin r. We can substitute sin r by using this small triangle. Opposite r divided by hypotenuse r squared plus h squared root. Then we can subject refractive index n value. We can cancel out r and r. Then n is 2 times square root of r squared plus h squared divided by 4r squared plus h squared root. Then answer is 2. Number 13. A glass tube of side 25 centimeters and refractive index 1.5 contains a small air bubble. When viewed through the block from one side, the air bubble appears to be 12 centimeters from that side. When viewed from opposite side, how far will the air bubble appear from that side? I will consider this one is the given tube. Side length is given as 24 centimeters. If this one is the air bubble, we can observe air bubble from this side. The distance, apparent distance is given as 12 centimeters. We can use the relationship between apparent depth and real depth, but there is another easy method. Refractive index of this medium is 1. Refractive index of this medium is 1.5, it means 3 over 2. I will get the ratio between two refractive indices. Ratio is 3 to 2. We can divide 3 over 2 by 1, then ratio is 3/2. It means 3:2. We know that this medium is the denser medium and this medium is the rare medium. When observing an object in a denser medium, the apparent distance is less than real distance. Therefore, we can get the relationship by using this ratio. If the apparent depth is 2 centimeters, real depth is 3 centimeters. If the apparent distance 2, real distance 3. But we have given apparent distance as 12. It means real depth should be 18. We can use proportional method. Then the air bubble should be placed 18 centimeters with a 18 centimeters distance. Now I will consider the observation from opposite direction. Now real depth is 6 centimeters because of this total length is 24. Again we can use this ratio. If the real distance, real depth 3, we can see apparent distance is 2. But actual real depth is 6, therefore apparent depth should be 3 times 2, 6, 2 into 2, 4. Then we can observe the air bubble 4 centimeters, air bubble with the 4 centimeters depth from the other side. Then answer should be 5. A ray of monochromatic light I approaches a spherical air bubble in a block of glass as shown in the figure. Which of the parts shown best represent the emergent ray? There is a problem related to given incident ray. Incident ray should be like this. They have given the incident ray is fallen to the midpoint, not midpoint. Incident ray should be fallen above the midpoint of diagram. Now this medium is denser medium and this medium is rare medium. Therefore, we know that perpendicular line is the radius of the sphere. The ray should be refracted from the perpendicular line, and then it should move in a path like this. Then again, perpendicular to this place is radius. Now this medium is denser medium, therefore ray should be refracted towards the perpendicular line. Then we can get correct ray is A. Then answer is 1. A towering microscope is focused upon a mark at the bottom of an empty beaker. Now the microscope is raised by 1 centimeter. To what depth should water be poured into the beaker so that mark can be again in focus? We have to use the equation to the apparent displacement. Now the apparent displacement of the given mark due to the liquid layer should be 1 centimeter because of the towering microscope has moved 1 centimeter in upward direction. Then we can use apparent displacement is T times 1 minus 1 over n. Outer medium is air medium, therefore we can use 1 for this place. But if the outer medium is not a medium, we have to use corresponding refractive index of the outer medium for this numerator. Now, outer medium means observing medium. We have placed I in this medium. Now the outer medium, therefore refractive index is 1. Then displacement, apparent displacement should be 1 centimeter. We have to find the thickness of the liquid layer. 1 minus 1 over n. Refractive index of water is given as 4 over 3. Then 1 over 4 over 3 means 3 over 4. Now we can simplify it. 1 equals t times 1 minus 3 over 4 means 4 over 4 minus 3 over 4. Then 1 over 4. Then thickness should be 4 centimeters. Answer is 2. When an object O is kept in front of a thick plane mirror formed by a silver in one side of the thick glass plate as shown in the figure. A series of images I1, I2, I3 can be observed. Which of the following statement is correct? We have to consider the reflection, partial reflection and refraction. For the incident ray, this surface is the silver-plated surface. This surface is the first surface of the mirror. Then the light ray is refracting at this place. Therefore, this ray is partial reflection. Then I1 image is formed by the partial reflection. We know that when considering partial reflection, there is a small energy when compared with refraction. Therefore, at this point, there is a refraction. It is a full refraction. Reflection. It is a full reflection. Therefore, this I2 image should be brighter than I1 image, because of I1 is formed due to the partial reflection. If this ray has 100 energy, this part is 10, about 10. This part is 90. Then there is a full reflection due to this silver-plated surface. Then I2 has a high intensity. After this phase, after this point, ray is refracting to the outer medium. There is a partial reflection into the glass medium. Therefore, when making third image, it is partial. It has a low intensity than I2. Then we can get I2 is the brightest and intensity of images I3, I4 decrease gradually. Answer is 2. 17. Consider the following statements made regarding the refraction of light. Statement A. Refractive index of the medium is equal to the ratio speed of light in vacuum divided by speed of light in medium. Yes, it is correct. Then B. As light travels from one medium to another, its frequency does not change. It's also correct. We know that frequency is depending only on source, it is not depending on the medium. Statement C. The wavelength of the light is reduced when it passes from vacuum to a medium. When passing a vacuum to a medium, frequency constant, velocity decreasing, then wavelength is decreases. Now they have given the wavelength of light is reduced when it passes from vacuum to medium. Yes, it's also correct. All ABC are true. Then answer is 5. Then question number 18. A ray of light travel in water, refractive index N1. Incident on air, water boundary at the critical angle. When a layer of oil, refractive index N2 is floated on the water surface, the angle of refraction of this light ray in oil is. For the first situation, outer medium is air, inner medium is water. You have to consider the ray with incident with critical angle. Then refractive index of water is given as N1, air medium 1, refractive index 1. Then we can write critical angle sin C equals to 1 over N1. Then for the second situation, there is an oil layer. Therefore, this ray is not the ray with critical angle for the oil-water interface. Now we have to find angle of refraction of light ray in oil. It means we have to find this R angle. Then I will use now refractive index for the oil medium is N2. Then I will use Snell's law for this point. N1 into sin C equals N2 into sin R. N1 into, we can substitute sin C value as 1 over N1, N2 into sin R. We can cancel out N1. Then sin R equals 1 over N2. R equals sin inverse 1 over N2. Then answer is 1. Then question number 19. The refractive indices of water and gas are 303 and 302 respectively. The refractive index of gas relative to water. Refractive index of gas relative to water means GNW. Refractive index of gas relative to water. We can write this one. Refractive index of water divided by refractive index of gas. We have to remember it. The refractive index of water is given as 4 over 3. We have to divide by refractive index of gas 3 over 2. We can multiply by the reciprocal. Then 8 over 9 is the relative refractive index of refractive index of glass relative to water. Then 8 over 9 is third answer. Refracting index of red color and blue color, red light and blue light in crown glass are 1.51 and 1.53. It means refractive index of red color is less than refractive index of blue color. Part A, consider the following statement. Part A, the speed of red light and blue light in vacuum are in the same. Yes, in vacuum there is the same velocity. For a medium there are different velocities. Part B, the speed of red light greater than blue light in crown glass. Refractive index of blue light is greater than refractive index of red light. We know that refractive index of is C over V. C means velocity of light in vacuum divided by V means velocity of light in corresponding medium. Therefore, when refractive index is increasing, velocity of light should decrease. Then velocity of blue light should be less than velocity of red light in count glass. Now I will read the statement again. Speed of red light greater than blue light in count glass. Yes, it also correct. See, critical angle of red light is greater than that of blue light of count glass. We can write critical angle sin C equals 1 over N. According to this relationship, when refractive index is a greater value, sin C is a smaller value. Therefore, sin C is small for the blue color. When sin value is decreasing, C value also decreases. Therefore, critical angle is of blue light is less than critical angle of red light. They have given critical angle of red light is greater than critical angle of blue light. Then C also correct. All ABC true. Answer is 5. Consider the following statements made regarding a monochromatic light ray refracting through a glass prism placed in air. Part A. The speed of light ray inside the prism is lower than that of outside of the prism. Yes, it is correct. Denser medium is glass medium. Rare medium is air. Therefore, speed of light ray inside the prism is lower than outer medium. Then statement B. The frequency of light ray inside the prism is lower than outside the prism. It is false. Frequency is not depending on medium, it is depending only on source. C. The wavelength of the ray inside the prism is lower than outside the prism. We can use V equals S lambda. Inside the prism, velocity is a small value, frequency constant, then lambda is a small value. They have given the wavelength of light ray inside the prism is lower than outside. It is correct. Only A and C true when answer is 4.